Hopefully we remember these, but we're going to go over it, so if not, it's okay. So y equals the square root of x. When we have a square root in a function, this is literally known as a square root function. That is its name. And on a graph, one way to remember this is the r. It almost looks like an r on a graph. So if here's your graph, and if you use this as your line, then you're going to have like a little r sticking out of it. Then we have y equals x squared. This exponent means that we have a quadratic. All right, and if we do a quadratic on a graph, we're going to get a parabola, so a U shape. All right, C says y equals the absolute value of x. This is another easy one. This is literally just absolute value. And on a graph, an easy way to remember this one is absolute value gives you a V, and we're going to have a V on our graph. And then y equals x. This is the original parent function. This is a linear equation. This is what we compare when we're looking at reflection, vertical shifts, those kind of things. So this is just a line. So linear means we have a line. All right. The next part says to evaluate each expression. A through H, all of these can literally be typed into your calculator. A few things I do want to refresh your memory of. These absolute value bars are going to change anything that's negative to a positive. A cubed root on your calculator, if you go to math, you can scroll down. I think it's the fourth option on there to give you a cubed root and type that in. Same thing for G. So just make sure you're typing these in the calculator correctly and you'll get your right answer. So for A, we're going to have 14. For B, we're going to have 0.89. All the absolute value does is just mean it's the positive value, which this was already positive, so nothing changes. For C, we've got 39. For D, we're going to have -4. Now, the reason this one is negative outside of these absolute value lines is because we have a negative on the outside. E, we're going to have 5. For F, we've got -6 times -6, which is going to give us positive 36. For G, we're going to get -4. And for H, we're going to get 9. So I know I didn't go into super amount of depth on these, but these are literally just expressions that you should type into your calculator. All right, number 3, we got to think back a little bit. This was our very first lesson. So it says, which numbers in set A are elements in both set B and C? So we were given these list of numbers that belong to set A, and set B wants multiples of 6. So out of these, let's pull all the numbers that are multiples of 6. So we're going to have -18, 0. Anything, remember 0 is always going to be able to be multiplied by 0, right? So then we have 12 and 24. 6 times 0 is going to give us 0, so it is a multiple of 6. Set C says natural numbers. Remember, natural numbers are counting numbers, so nothing nothing negative, and it has to start with 1 and go up from there, so no zeros. So our natural numbers are going to be 14, 12, 15, 24, and 32. Now the question said which one belongs to A, B, and C. So we need to look at B and C and see what numbers we have that are the same. It looks like we just have 12 and 24. So our answer is, that's bad, 12 and 24. Force us to tell if the graph or table represents a function. Remember, we can look at a graph and do the vertical line test. This one obviously would not pass the vertical line test, so this is not a function. All right, then for B, we need to look at our x values and our y values and determine if this is a function or not. So our y values do repeat, but notice this is the same point. They're both -3 and 9. So because it's the same point, that is all right. That means that this is a function. If they were different, it would not be, but because they are the same, it is. Right, for C, once again, we can do the vertical line test. This doesn't have any 2 points touching at the same time, so C is a function. Hopefully you have your study guide printed out and you're following along with this video as we go. Feel free to pause it and catch up. All right, 5 says examine the function g of x at the right to answer the following questions. So we need to remember that g of x is our x value and g of x equals a number is our y value. So what this is asking us to do is just to find the ordered pairs that belong to these numbers on the graph. So g of negative 2 means that we need to look at x equals negative 2. So x of negative 2 is right here. Where's the point on x equals negative 2? We're going to go down and find that it is on negative 7. So our ordered pair here is negative 2, negative 7. G of 2 means we need to find where x equals 2. So here's x equals 2. Where's our line on this graph? Where's our point on this graph? So it's going to be 2, negative 2, positive 1. All right, then we have g of x equals negative 7. This means we need to look at y equals negative 7. So y equals negative 7 right here. We've already found one point, but there is also one more. So we'll write both of those. So our first one is negative 2, negative 7, like we already found. And our second point is going to be 3, negative 7. Make sure if it's a y value, you're writing it second. Just because this is what they gave us first does not mean we would list it first. Right, g of x equals 1 means to also look at the y value of 1. So here's our y value of 1. We already have one point here, and our second point looks like it's going to be over here. So we're going to write 2 and 1 just like we already had and found. And then our second ordered pair is going to be negative 4 and 1. Right? Number 6 says for the following functions, tell whether they are even, odd, or neither. Hopefully we all remember how to find this, but if not, I'll refresh your memory. An odd graph is going to be the same upside down. An even graph is going to have symmetry over the y-axis, and then neither means it doesn't meet the standards either way. So A is a graph, and it would look the same if we rotated this upside down. So this is going to be odd. When we're looking at actual equations, we need to look at the coefficients that are down here. We need to look at the exponents, whether they're odd or even. So we've got an even, we've got an odd. Remember, this is an imaginary one, so we have an odd, and then we have a coefficient. That means that this is not going to be odd or even because it's got even and odd exponents. So this is neither. For C, we have this perfectly symmetrical parabola across the y-axis. Means we could fold it in half right here and get a mirror image on both sides. So that means this graph is even. All right, let's go ahead and keep going. Sorry, I had to flip my paper over. All right, number 7 wants us to look at the domain, the range, and is it a function. So let's remember how to do this. Remember, we're looking at the first x to the last x and the first y to the last y. For x, we read left to right. And for y, we read bottom to top. And then we use the vertical line test to determine if it's a function. So our domain here means we need to look at x. Notice we have a closed circle on the end, meaning we're not going past this point on the graph, which looks to be negative 3. So we've got negative 3. And then our last x value is going to be infinity. So what this means is when we write this out, we'll write our first, we have negative 3, less than or equal to y, less than or equal to infinity. Okay, then we don't want this infinity in here, but we can't end with y, so we're going to flip it, and we have y is greater than or equal to negative 3. Remember, if you put your y in the front, you have to flip that sign. All right, for our r, oh, I put y. My bad, guys, this is x. All right, then for our range, our first y value is the first y point on this line, which is negative 4. And our last y value is going to be way over here up into infinity. So our last y value is also infinity. So we're going to have y, and that's going to be negative 4 less than or equal to y less than or equal to infinity. And once again, we don't need this infinity, so we're going to flip it. We get y is greater than or equal to negative 4. Is this a function? Does it pass the vertical line test? The answer is yes. All right, for 2, notice we've got arrows on both ends, meaning we've got infinite on both ends, right? So infinity and infinity, whether it's x or whether it's y, we're going off the graph. So that means when we have infinity on both ends, we're going to equal all real numbers, and that's going to be the case for x and y here. Does it pass the vertical line test? The answer is yes. All right, for 3, notice we've got a stopping point here and an arrow over here. So when we look for our first x value, we're going to have infinity, and our last x value is going to be 3. So when we write this out, we're going to have infinity is less than or equal to y is less than or equal to 3. Once again, we don't want the infinity, but the y is already first here. So we've got y is less than or equal to 3. All right, why do I keep writing y? I'm sorry, guys. This is x. All right, then for our y value, our first y value is going to be negative 1. And our last y value, once again, is infinity. So we're going to have negative 1 less than or equal to y less than or equal to infinity. We drop the infinity. We want y first, so we flip it. So we have y is greater than or equal to negative 1. Does this pass the vertical line test? The answer is yes. So this is also a function. So all 3 of these are functions. All right, number 8 says to find the equation. So we were given the slope and we were given a point, but we don't have a b value. So we need to find that by plugging it in. Remember, y equals mx plus b. So we're going to take this ordered pair, plug it in for y and x, and put 1/3 in for m and solve for b. So we're going to have 11 equals 1/3 times negative 6 plus b. We get 11 equals negative 2 plus b. We're going to add that 2 to the other side, and we get b equals 13. So now we know what b equals. We know our m, so we can write our equation as y equals 1/3 x plus 13. For b, we are given 2 ordered pairs, so the first thing we need to do is find our slope. So we're going to use this formula. Hopefully we all remember this to find our slope. So we've got 4 minus 0 over negative 4. Negative 4 minus 7 over negative 4 minus 0. When you plug this into your calculator, if you work it out in your head, you're going to get 3/4. 4 minus 7 is 3. Negative 4 minus 0 is 4. These were both going to be negative, so you'd leave a negative 3 and a negative 4 over. A negative over negative is going to give us a positive. So now we can plug this in. So luckily on this case, we're already given our y-intercept. Remember, if it has an x value of 0, an x value of 0 means y-intercept. So we don't have to solve for our y-intercept. We know it's going to be 0, 7. So our formula is going to be y equals 3/4 x plus 7. For C, we have a slope of negative 2 passing through 0, 7. So we were already given our slope. And look here again, we were already given a y-intercept. So we can go ahead and write our equation. Y equals negative 2x plus 7. All right, for D, once again, we were given 2 sets of ordered pairs. So we're going to do m equals 5 minus negative 2 over negative 3 minus negative 4. When we plug this all in, we're going to get 7. But we don't have a y-intercept here, so we need to solve for that. So we're going to pick an ordered pair. In my case, I chose negative 3 and 5. You could pick either one. And we're going to plug it back into this formula. So we're going to have 5 equals 7 times negative 3 plus b.
Blue, third lunch, grab and go. Report to the cafeteria. Blue Day, third lunch, grab and go.
All right, then we're going to continue to work this out. So we have 5 equals negative 21 plus b. We're going to add that 21 to the other side, and we get b equals 26. So now we know our m, we know our b. So y equals 7x plus 26. Hopefully all of this is coming back to you and making sense. All right, number 9 says to evaluate the function with the given information. So all this is inputs versus outputs. Remember, if it's inside of the parentheses, it's an input, and if it's outside of the parentheses, it's an output. Right? So we were given the way to read these. This is the function that we're working with, and this is the given information. So f of negative 5 is inside parentheses. This is an input. So we're going to plug it in for x. So we've got 10 minus negative 5. This is really going to be 10 plus 5 because a negative minus a negative is going to become a positive. So we have y equals 15. For b, we were given f of x equals 8. This is outside of the parentheses. This is an output. So we're going to have to plug it in for f of x. So we get 8 equals negative x minus 7. We're going to add that 7 to the other side. We get 15 equals negative x. We don't want our x to be negative, so we're going to divide by negative 1, which really is just flipping the signs. So x equals negative 15. For c, we have f of negative 10. This is an input. So once again, plugging in for x. So we're going to have y equals 8 over negative 10 minus 6. Negative 10 minus 6 is going to give us what? Negative 4. So we have 8 over negative 4, which reduces to negative 1/2. So y equals negative 1/2 is your answer. For d, we were given f of x equals 17. This is an output. It's outside of the parentheses. We're going to plug it in for f of x. So we get 17 equals 11x minus 5. We're going to add 5 to both sides. We get 22 equals 11x. We're going to divide by 11, and x equals 2. Right? The biggest thing there is just to make sure you're putting your number exactly where it should go. All right. Number 10 wants us to find the m, the b, and the equation. This is our slope, our y-intercept, and our equation. So notice this is asking for b, so we don't have to write this. So if it's a y-intercept, this means ordered pair. And if it's a b, this is asking for the y value of the y-intercept. All right, so let's find our slope. So first, let's find a point. So we've got a point here, and we have a point here. We'll make our slope triangle. We go up 1 and over 2. So our slope is going to be 1/2. Our b is where we're crossing this y-axis, which is going to be right here, which is negative 2. So we can write our equation, y equals 1/2 x minus 2. Hopefully we remember how to find the slope of a table. If not, we subtract backwards. So 4 minus 2, 2 minus 0, 0 minus negative 1, and negative 1 minus negative 2. All of this is going to give us 4 minus 2, 2, 2 minus 0, 2. It brings 2 all the way down. And then on this side, we've got 35 minus 25, that's 10. 25 minus 15, that's 10. 15 minus 10, also 15 minus 10. Is going to give us 5, and 10 over 5, 10 minus 5 is going to give us 5. So, negative 1, oh, I didn't even do that correctly. So notice our slope changes. We have 0 minus negative 1 is 0 plus 1, so we have 1, and then negative 1 minus 2 is going to be negative 1 plus 2, which is 1. So if you notice, we've got 10 over 2, And we also know that that reduces to 5 over 1. So these are the same slopes. So this is fine. This is a common rate of change. So this is going to be a slope of 5, m of 5. Remember to find our y value. We're going to look for an x value of 0. So that's going to be right here. So our b is 15. Then we can write our equation. Y equals 5x plus 15. So good example of not to do what I do and rush through it and just assume that it's all the way down. Make sure you're actually checking these. Alrighty, let's see what's next. So we have number 11. It says write equations for the following situations, then answer using the correct units. So we first have A, which says scuba diving lessons cost $89 per hour plus a one-time equipment fee of $150. Joey must complete 5 lessons to become a certified diver. How much will this cost him? So let's first find out what our x and y variables are going to be. So we have x and we have y. So let's read what the question is telling us. So it says $89 per hour. This is our rate of change. And a one-time equipment fee of $150. This is our initial value. So what is changing here? This is our rate of change, which we know should include our x variable. So this is cost per hours. So we've got hours or amount of lessons because we know that 1 hour is 1 lesson. And then our y value is going to be, what is this total cost? And you can kind of figure that out by the question it asks you. It says, how much will this cost him? So that's what we're trying to figure out. So let's make our formula. Y equals 89x. That's our rate of change. And our initial value is 150. So plus 150. Okay. Now it says, if he completes 5 lessons, how much will this cost him? So we know that it's $89 per lesson. So we're going to do y equals 89 times 5 because we want 5 lessons plus 150. So we can plug this whole thing into our calculator and we're going to get y equals 595. Make sure to answer it in correct units, which means we need to have a dollar sign. So $595. All right, B says a 30-inch sheet of plastic is melting by 2.5 inches per hour. How long will it take for the sheet to melt completely? So let's figure it out. So we've got melting by 250 per hour. This is our rate of change. This is our rate word right here. And we're melting, so we're going to be negative 2.5x. And then it does not look like we have any sort of initial value. Oh yeah, 30 inches. This is our initial value. So it wants to know how long will it take the sheet to melt completely, meaning we want to know when will it equal 0. Like all of it is gone. So let's set up our equation first. We're going to have negative 2.5x plus 30. All right, so then let's say, what do x and y equal here? X here equals 2.5 inches per hour. So this is hours per hour. This is what our x stands for. And then y is going to equal the total amount left, right? So the inches that are there. So we've got our equation. Now let's work it out for what the question says. It says, when will the sheet melt completely? Which means we need to set our y equal to 0. So we're going to have 0 equals negative 2.5x plus 30. We're going to subtract 30, so we get negative 30 equals negative 2.5x. We're solving for x, so we're going to divide by negative 2.5. So negative 30 divided by negative 2.5 is going to give us 12. So notice we're talking about hours. So x equals hours, so this is going to take us 12 hours for the whole sheet to melt. Okay, let's keep going. All right, number 12 says to describe the transformations that have taken place when compared to the parent function y equals x. So we remember this hopefully is 1x plus 0. And this is the same thing. So we're comparing our slope. Does the sign change? Does it increase or decrease? And does our initial value increase or decrease? So first we notice our slope is negative. So that negative tells us we have a reflection.
Orange. Third lunch. Dine in. Report to the cafeteria.
All right, but then we need to look at the actual number of slopes. So we went from 1 to 2. So that 2 tells us, remember with slope we're talking about steepness versus flatness. So this 2 is bigger, so we're going to be 2 times steeper. And then our initial value went from 0 to 5. This is talking about this is our y-intercept, so it's talking about where we are on the y-axis. So if we went from 0 to 5, we went up 5, so vertical shift of 5. All right, on the next one, our slope stays positive, but it decreases from 1 to 1/2. So it's 1/2 is smaller than 1, so we're going to be 1/2 times flatter. Then our initial value went from 0 to -4. So we moved to the -4 y value spot. So that means we have a vertical shift down 4. All right, for C, we have y equals -4x. Notice our slope changed in sign, so that negative means we have a reflection. But then we went from 1 to 4. 4 is bigger than 1, so this is going to be 4 times steeper. And then our initial value didn't change. We went from 0 to 0, so it stays, so no vertical shifts. All right, number 13 says solve each equation for x. So literally we're just going to solve these equations. So first thing we need to do is distribute this 4 out. So we're going to have 4x plus 20 equals 24. We're going to subtract 20, and we get 4x equals 4. To get x alone, we're going to divide by 4. So 4 divided by 4 is going to give us 1. All right, for B, we have x over 4 plus 3 equals 7. So the first thing that we need to do is subtract this 3, right? This is technically a grouping. So we're going to be left with x over 4. And then 7 minus 3 is going to give us 4. And then to get x alone, we're going to multiply by 4 on both sides. So we get x equals 16. All right, for C, we can't touch anything on top right now because that's technically a grouping. So the first thing that we're going to do is multiply by 6 on both sides to get rid of that fraction. So we're left with x minus 4 equals 30. Then we're going to add 4 to both sides, so x equals 34. Right? Not too bad. Number 14 says, which value would not be a part of the domain for f of x equals 15 over x minus 9? So what this is saying is, when is the denominator, which means the bottom, hopefully we know that, equal to 0, right? So if we have -9, what would make that 0 on the bottom? Well, 9 minus 9 is going to equal 0, right? So we have the answer is 9. Right, let's keep going. So this is a long study guide, so bear with me. All right. Number 15 says to simplify each expression. So we need to remember the exponent rules here. When we multiply exponents, we add them. And when we divide exponents, we subtract them. Okay? So we have to first multiply our actual coefficients, right? So we're just distributing this out. So we're going to have 5 times 2 is going to give us 10. Then we have x to the 4th power, x to the 4th power. We add those and get x to the 8th, and then we bring y to the -3rd down. Remember, we cannot leave any negative exponents in our equation, in our answer. So we need to move this to the bottom and create a fraction. So we're going to keep 10x to the 8th on top. That was positive. This is fine. And then y to the -3rd is going to go to the bottom and become positive. Okay, for B, we're going to subtract. So we have x to the 6th over x to the 5th, which is going to leave us with 1x. Just going to put that there so we remember it. And then y to the 5th minus y to the 8th is going to give us y to the -3rd. So again, we have a negative number, so we need to put x on top. We can leave the 1 out this time. And then we have y to the 3rd becomes positive on the bottom. All right, we have 3x to the 0 power. Anything raised to 0 equals 1. So this is going to be 1. All right, then it says for the generic rectangle below, find the dimensions, length, and width, then write the area as factors equal to a product. Don't let these fancy words confuse you or throw you off. All we're doing is filling out this box and then showing what we factored out and what we would get. So we have 5x squared. We know 5x went into that, so 5x times what would give us 5x squared? That means this has to be x. All right, and then for this one, we've got negative 9. Well, we know that 3 times something has to give us negative 9 right here. So what times 3 is going to give us negative 9? Well, the answer is negative 3. So then we can fill in the gap. So we have 3 times 5x. That's going to give us 15x. And then x times negative 3 is going to give us negative 3x. So all we're going to do on this first part is just write out what we're multiplying by each other. So we have x plus 3 times 5x minus 3. And then we're going to write our answer over here. So we have highest exponent first, 5x squared. Our 15x and our negative 3x are going to cancel 3 of these out. So we're going to be left with plus 12x. And then we have left over negative 9. All right, number 17 says to use the distributive property or a generic rectangle to simplify the following expressions. So we're going to start with this one first. I'm going to use the FOIL method. Hopefully remember FOIL is first, outer, inner, last, which means we're going to go first. That didn't go where I wanted it to. First, outer, inner, last. So we have 3x times x. That's going to give us 3x squared. All right, and then we have 3x times 5. That's going to give us 15x. Negative 7 times x is going to give us negative 7x. And then negative 7 times 5 is going to give us negative 35. So we just combine like terms. So we have 3x squared. 15x minus 7x is going to give us 8x minus 35. All right, remember that anything squared is being multiplied by itself. So we have 3x minus 5 times 3x minus 5. Then we can distribute that out. So 3x times 3x is going to give us 9x squared. 3x times negative 5 is going to give us negative 15x. Negative 5 times 3x is also going to give us negative 15x. And then negative 5 times negative 5 gives us positive 25. Then we combine our like terms. So we have 9x squared. We have 2 negatives here, so they don't cancel out. They actually add. So we're left with negative 30x plus 25. All right. For C, I'm going to do a rectangle just to remember how to do it. Usually when there's 3 terms, I like to use the rectangle method. So we have x squared minus 3, and then 3x squared plus 5x minus 4. We multiply it out. Negative 3 times 3x squared gives us negative 9x squared. Negative 3 times 5x gives us negative 15x. Negative 3 times negative 4 gives us 12. X squared times 3x squared gives us 3x to the 4th power. X squared times 5x gives us 5x cubed. Don't forget to add your exponents. Then x squared times negative 4 gives us negative 4x squared. So then we write this out with the highest exponents first, which is 3x fourth. So we're going to have 3x to the 4th power. Right, then this one's gone. Then we have cubed. There's no other cube, so we're going to have plus 5x cubed. Right, then our squared is next. So we have negative 9x squared and negative 4x squared. So since these are both negative, they're really going to add, become negative 13x squared. Then we're left with negative 15x plus 12. All right. 18 tells us to solve for y, which just means we want to put this in slope-intercept form. So we're going to start by subtracting 3x from both sides. We get negative 7y equals negative 3x plus 35. No, that's minus 35. Then we're going to divide by negative 7. So negative 3 divided by negative 7 is going to give us positive 3 over 7x. And then negative 35 divided by negative 7 is going to give us positive 5. Okay? For b, we're going to do the same thing. We're going to start by subtracting 4x from both sides. We get negative 2y equals negative 4x plus 12. Then we're going to divide by negative 2. So we get y equals negative 4 divided by negative 2 is going to give us positive 2x. And then 12 divided by negative 2 is going to give us negative 6. All right. 19 says to rewrite the following equations into slope-intercept form, state the slope and the y-intercept. So it just wants us to put this in slope-intercept form, which is essentially solving for y, and then breaking it down over here. So we're going to start the same way we just did by subtracting our x's from both sides. We get negative 4y equals negative 2x minus 12. We're going to divide by negative 4. So negative 2 divided by negative 4 is going to give us positive 1/2 x. And then negative 12 divided by negative 4 is going to give us positive 3. So we can write that equation over here. We have y equals 1/2 x plus 3. Our m is 1/2 and our y-intercept. Notice it's asking for a y-intercept, not our b. So we have to write this as an ordered pair, which is 0, 3. All right, for b, we're going to start by adding x to both sides. We get 3y equals x minus 15. We're going to divide by 3. Remember there's an imaginary 1 here, so we never put x in the fraction. We have 1/3 x, and the negative 15 divided by 3 is going to give us negative 5. We can change that, write that over here, so y equals 1/3 x minus 5. Our m is 1/3, and our y-intercept is 0, negative 5. Okay, the biggest thing is just to make sure you know the difference between your y-intercept and your b at this point. We should know that. We should have it down pat. All right, now we need to do the same thing, but we were given a chart, a graph, and 2 ordered pairs. So for A, we need to find our slope first, which we do by subtracting up. So 5, 4, 3, 2, 1, it's obvious the side is 1. Then 8 minus 5, 5 minus 2, 2 minus negative 1, negative 1 minus negative 4, and negative 4 minus negative 7. All of these are going to give us 3. So our slope can be 3 over 1, or we can just write it as 3. All right, now it's asking for b, not our y-intercept, so we don't have to write this as an ordered pair. But in order to find our b, we need to look where the x value is 0. Oh, that's rough. So we found that right here, so our b is negative 7, which means our equation is going to be y equals 3x minus 7. All right, now we need to find our graph. So let's start by finding our slope. Notice we are decreasing. This means we are going to be a negative slope. So we've got 1 point here, so we're going to go down 1, 2, and over 1. So negative 2 over 1. We can just write this as negative 2. Our b is where we're crossing the y-axis, which looks to be 5. So our equation is going to be y equals negative 2x plus 5. All right, for C, we were given 2 ordered pairs, so we need to figure out what the slope is. We're going to do this the same way we've been doing. So m equals negative 3 minus negative 5 over 6 minus negative 2. This is going to give us 1/4. And now we need to solve for b. So you can use either ordered pair. I'm going to use 6 and negative 3. So we're going to have negative 3 equals 1/4 times 6 plus b. We get negative 3 equals 3 over 2 plus b. And then we're going to subtract that 3 over 2. So negative 3 minus 3 over 2 is going to give us negative 9 over 2. So our slope is 1/4. Our b is negative 9 over 2. And our equation is y equals 1/4 x minus 9 over 2. Bear with me, guys. If you need to pause and come back, I totally understand. But make sure you're focused and you're not losing interest in the video. All right, D says, due to the recent storms, the river is rising at a rate of 5 inches a day. The normal level is 27 feet. The depth of the river in inches, y, is a function of the number of days, x. So we need to figure out what our rate of change is, what our initial value is, and what our equation is. So notice it says that the river in inches y, so that means y is going to equal our depth in inches. And then x, it says, is our number of days. All right, so we need to think of a few things first. Hopefully we know, okay, we're rising at a rate of 5 inches a day, but then we're talking about the normal level in feet. So we need to know that 1 foot equals 12 inches. So we are rising at a rate of 5 inches a day. That means that is our rate of change right there. So 5 inches a day. All right. And then we need to figure out, what does 27 feet mean in inches? Because we want to know the depth in inches. So that means 27 feet needs to be multiplied by 12. So 27 times 12 is going to give us 324 inches. Okay, so our initial value is 324 inches. We have to make sure we're writing this in the right unit. So if it's asking for the depth in inches and it gave it to us in feet, we have to convert it. So then our equation is going to be y equals 5x plus 324. All right, number 21 says, using the graph shown, answer the following. Write your response using interval notation. So it says to find an interval where the graph is increasing. Well, we read a graph left to right, just like a book. So when we're increasing, we start over here. Notice we're increasing, and then we're decreasing, and then we just kind of flatten off. So it says, where is the graph increasing? Well, that's going to be from this point to this point. So our first point is going to be -2. And then our last point, we're looking at x values. X values is going to be 0. All right, we're decreasing from this point to this point. So our x value here is 0. And our last x value is +2. So that looks a lot more complicated than it is, but it's really not difficult at all. All right, solve these systems using the method of your choice and write an answer as an ordered pair. Let me scroll this down so we can see all of these options on here. All right, so you need to be able to evaluate what you're going to use and what is the best way for you to do it. So on A, I'm going to use elimination and make this y a -y. So I'm going to bring the first one down. Multiply this whole thing times -1, we get -x minus y equals -4. Then our y's cancel out. 7x minus x leaves us with 6x. 10 minus 4 gives us 6. We divide by 6, so x equals 1. Then we can plug this x value back in and solve for y. So we have 1 plus y equals 4. We're going to subtract that 1, so y equals 3. So our solution here is 1, 3. Remember, ordered pairs are written x, y. All right, for this next one, notice they both equal y. So this is a really good opportunity to use equal values. So I'm going to set them equal to each other. 1/2 x minus 5 equals 1/2 x plus 3. All right, regardless of which side we subtract this 1/2 x from, they're going to cancel out, right? Because they're both positive. So if we subtract it from either side, it's gone. So then we have -5 equals 3. The question is this true? Obviously, -5 does not equal 3, so this is no solution. All right, for C, notice we've got 1 already set to y, so I can use the substitution method and plug that in and solve. So we have -6x plus 2 times 3x plus 4. We know that that whole thing, 3x plus 4, equals y, and then equals 8. So we have -6x, then we're going to distribute that out, plus 6x plus 8 equals 8. So notice our x's cancel out, and we're left with 8 equals 8. Is this true? Does 8 equal 8? It does. So this is infinitely many solutions. Right? For D, once again, we have a value for y. Y equals -1. So we're going to just plug that in right here. We don't even have to solve for y. So we have -3x plus -1 equals 2. So then we get -3x minus 1 equals 2. We're going to add that 1 to the other side. So we have -3x equals 3. Then we're going to divide by -3. So 3 divided by -3 is going to give us -1. So our ordered pair here is -1, -1. It already gave us a value for y. We don't have to solve for that. All right, number 23. Ashley and Chris are saving money for a vacation. Ashley currently has $4,500 and is working hard to save $150 per month. Chris only has $2,000 in savings, but is saving $250 per month. And how many months will they have the same amount in savings? So when the question asks you anything about when it will be the same, that's a key that we're going to, don't know what I'm writing. That's a key factor that we're going to use equal values. So we're going to define our variables first. We've got x and y. All right, so what we're going to be doing here is making an equation for Ashley and making an equation for Chris. So she's got $4,500 and is saving $150 per month. Anytime you see per, that's a rate word. So this is our rate of change. This is our initial value. This is our rate of change. And this is our initial value. So this $250 per month is telling me that we're going to have 250x. So our x is going to equal months. And then our y is going to equal the total amount saved. If we combine this $150 per month and what they have in savings, the y will tell us their total amount saved. So then we need to write our system of equations for each. So for Ashley, we're going to have y equals 150x plus 4,500. And for Chris, we're going to have y equals 250x plus 2,000. Right, and then we want to set those equal to each other to find out when they're going to have the same amount of savings. So set those equal to each other. I'm going to start by subtracting 250x. You could do it either way, but I'm going to start by subtracting the 250x. That's going to leave me with -100x plus 4,500 equals 2,000. Then we need to subtract 4,500. So we have -100x equals -2,500. Then we're going to divide by that -100. So -2,500 divided by -100 gives us 25. So this tells us if x equals 25, we know that x is months. So in 25 months, they will have the same amount of savings. Okay? All right, guys, we just have one more page left. I cannot believe we actually made it. Sorry if this video is so long, but we want to make sure you guys are prepared. So, number 24 says, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. So let's highlight that. 3 senior citizen tickets and 1 child ticket. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of the senior citizen ticket and the price of the child ticket. Well, if you're ever confused of your x and y's, the question will tell it to you. So it's very obvious we're looking for senior citizen price tickets and child ticket prices. So for x, we're going to do senior ticket price. And then for y, we're going to do child ticket price. We want to know how much each one costs. All right, so the first equation is literally given to you. 3 senior citizen tickets, that's 3x. 1 child ticket, that's 1y, equals $38. Then our second one, we've got 3 senior citizen tickets and 2 child tickets, equals $52. Right? And you can solve this whatever way you want. I notice we have 3x in both, so I can easily make one of these negative by multiplying by -1. So I'm going to bring the first one down the way it is. 3x plus 1y equals 38. You don't have to keep the 1 there. Obviously, I'm just doing it just to make sure that we're doing it all the right way. So then we're going to have this one multiplied by -1. You could pick either equation. So we're going to have negative 3x minus 2y equals negative 52, right? So then our x's cancel out. 1y minus 2y is going to leave us with negative y. 38 minus 52 is going to leave us with negative 14. If we want this y to be positive, so we divide by -1, which just changes the sign of both, and we get y equals 14. Now that we know that y equals 14, we can plug it back in to either one of our equations and solve for x. I'm going to solve it in the first one. So we have 3x. Because we have 1 there, that's going to make it easier. We don't have to multiply this y out. So 3x plus 14 equals 38. We're going to subtract by 14. We get 3x equals 24. Divide by 3, x equals 8. So that tells me that senior tickets are going to be x, which is $8, and children is going to be y, which is 14. So children are $14. All right, number 25 says to explain what each of the following possible solution depicts the graph of a system of equations. So think back on system of equations. We dealt with that for a very long time. If we have one solution, that means we've got intersecting points and one solution where they cross in the middle. If we have infinitely many, that means we have two lines right on top of each other. So these are coinciding lines. That means that infinitely many means every single point on coinciding. I think I spelled that right. And then if there's no solution, that means the lines never touch, which means they've got to run parallel to each other. Okay. This next part should be fresh on your mind, so we shouldn't have any issues with this. Arithmetic, geometric, common difference, common ratio, or is there a ratio? And then we're going to figure it out, okay? So 6, 12, 18, and 24. My first gut instinct tells me this is going to be arithmetic, which means we subtract. 24 minus 18 gives me 6. 18 minus 12 gives me 6. And 12 minus 6 gives me 6. So that works. That means this is arithmetic. Our A sub 1 is our first term, which is 6. An arithmetic equation means that we are going to have a difference. We just said it was 6. So we write our equation. Remember that arithmetic equations are written a certain way, which is the a sub 1 plus the difference times n minus 1. All right, for B, I originally think this is arithmetic. So we have 17 minus 11, and then 11 minus 6. Those give us two different numbers, so that doesn't work. So let's try dividing. So 17 divided by 11 gives us a crazy decimal, but let's see if 11 divided by 6 gives us the same decimal. It does not. You can double check for yourself if you don't believe me. So that tells me that B is neither, which means we don't have anything that we can write here. Okay. C, we've got 2, 14, 98, and 686. It's a big gap, so I'm going to go with geometric. So 686 divided by 98 gives us 7. 98 divided by 14 also gives us 7. And then 14 divided by 2, once again, is 7. So that works. This is geometric. Our a sub 1 is 2. We have a ratio of 7. And we write our equation for geometric as a sub n equals our a sub 1 times our ratio with n minus 1 as an exponent. Okay. For D, we have 180 all the way down to 20. First instinct tells me this is geometric. So 20 divided by 40 is going to be 1/2. 40 divided by 80, also 1/2. And 80 divided by 160, also 1/2. So geometric, yes. A sub 1, 160. Ratio of 1/2. So we're going to have a sub n equals 160 times 1/2, and then n minus 1 as an exponent. All right, E, we've got negative 40, negative 25, negative 10, and 5. These are smaller changes, so I'm going to start with arithmetic. So 5 minus negative 10, that's 5 plus 10, that's 15. Negative 10 minus negative 25 is negative 10 plus 25, also 15. Negative 25 minus negative 40 is negative 25 plus 40, which once again gives us 15. So arithmetic is correct. Our a sub 1 is negative 40. We have a difference of 15. And we write our equation a sub n equals negative 40 plus 15 times n minus 1. All right, we have 7 all the way to negative 189, which I'm going to first, based on my gut, go with geometric. So negative 189 divided by 63 gives me negative 3. 63 divided by negative 21 also gives me negative 3. Feeling good about this. Then negative 21 divided by 7, negative 3. So geometric, yes, a sub 1, 7. Ratio of negative 3. So we have a sub n equals 7 times negative 3, and then n minus 1. All right, for G and H, we've got some tables, but we're just looking at these y values, okay? We don't care what the x values are. So we do the same thing. So negative 8, 4, and negative 2. I'm going to say arithmetic. So negative 2 minus 4, that's going to give us 2. And then 4 minus negative 8 is going to give us 4. So that's not right. Let's check geometric. So negative 2 divided by 4 is going to give us negative 1/2. And then 4 divided by negative 8 also gives us negative 1/2. So the answer there is geometric. Our a sub 1 is our first number with our first term. It's 8, negative 8. We have a ratio of negative 1/2. And our equation is going to be a sub n equals negative 8 times 1/2, and then n minus 1. Okay, so here we've got 16, 22, and 28. Pretty confident this one's going to be arithmetic. So we have 28 minus 22. It's going to give us 6. And then 22 minus 16 also gives us 6. So it is arithmetic. Our a sub 1 is 16. We have a difference of 6. So we have a sub n equals 16 plus 6 times n minus 1. Okay, guys, we have 2 questions left. Can we do it? Let's see. Determine whether negative 230 is a term of the following sequences. So if we're trying to figure it out, we're going to plug it in. These are outputs for a sub n. So we have negative 230 equals negative 6 plus 3 times n minus 1. We get negative 230 equals negative 6 plus 3n minus 3. That gives us negative 230. Combine the negative 6 and the negative 3 to get negative 9 plus 3n. We're going to add 9 to both sides and get negative 221. And then we're going to divide by 3, and we get negative 73.67 equals n. This is a negative and it's a decimal, which means this is not a term. Even if it were just a decimal or even if it were just negative, that means it's not possible to be a term. We have to have a natural number. So let's try the second one. Negative 230 equals 25 minus 5 times n minus 1. We have negative 230 equals 25 minus 5n plus 5. Negative 230, combine 25 and 5 to get 30 plus 5n. We're going to subtract 30 from both sides and get negative 260 equals 5n. We're going to divide by, did I mess up something? Oh, look at that. Even I make mistakes. This should be negative 5. Negative 5 times negative 1 should give us negative 5. Wait, no, I did that right. I just didn't write this part down right. So this is a positive, but obviously when I transferred this down, I didn't write the negative sign. So we have negative 5n. We're going to divide by negative 5. So n equals negative 260 divided by negative 5 gives us positive 52. This is a natural number, so this is a term. All right, I really hope you guys learned something from this video and that it helps refresh your memory of all the stuff we've learned this semester. Good luck on your final exams, and I hope you all have a wonderful holiday break, and we'll see you back here after the next year.